So let's go ahead and talk about the problem of the day. Be sure to answer the questions that I ask out loud, and think about how your work is the same or different from what we talk about together. Remember, if something is hard for us, we try our best by using a strategy that helps us. I imagine most of you said that each sibling got 3/6 of the pan. Why would that make sense? Say it out loud. Yeah, so the pan is cut into 6 equal parts. So we're working with 1/6. If each sibling or twin gets half the pan, they would each get 3/6 because 3 is half of 6. To help us see this, I'm going to shade the top half orange. So that's 3/6 for one twin, and the bottom half green. That's 3/6 for the other twin. Okay, so take a look at how we've colored this pan. What is another fraction that would also represent how much each twin gets? Say it out loud. Oh yeah, 1/2. Why would 1/2 make sense here? Say it out loud. Yes, if the pan is one whole and there's 2 people sharing it, they each get half of the pan. So I drew a second pan over here on the left to help us see this fraction. I'm going to divide it in half like we just talked about. And I'll write underneath 1/2. Okay, let's also go ahead and color it just like we did the first one. The top half for one twin, the bottom half for the other twin. So we have 1/2 and 3/6. Are those amounts equal? Why or why not? Say it out loud. Yeah, they are, aren't they? Both 1/2 and 3/6 take up the same amount of the whole. So when you look at the picture with the halves first, okay? Start over here. And then you look at the picture of the 6th. What happened to the pieces? Say it out loud. Yeah, we actually divided the larger pieces into smaller pieces, didn't we? But we didn't change the overall size of the whole. I'm going to add dotted lines here to show how we did that. So one way that we can make equivalent or equal fractions is by partitioning the fraction into a greater number of smaller equal parts. We broke this fraction into a greater number of smaller equal parts. Read this key point with me. Go ahead. We can make equivalent fractions by partitioning the fraction into a greater number of smaller equal parts. So look at these two fractions. We know they're equal, but what happened to the numerator and the denominator when we went from 1/2 to 3/6? Say it out loud. Right. The numerator increased to represent the new number of parts that we're referring to. And the denominator increased to represent the new number of parts in one whole. And what's interesting is we can actually show this with multiplication. When we go from 1/2 to 3/6, how many times greater does the number of parts that we're referring to become? How many times greater is the numerator? Say it out loud. Right, 3 times greater. Each part that we had to start became 3 parts. We could show that by writing times 3. And what about our total number of parts? How many times greater did that become? Say it out loud. Yes, our total number of parts in one whole also became 3 times greater because all the parts got broken up into 3 new pieces. So we had 2 parts total in one whole, and now we have 6 parts total in one whole. We could show that again by multiplying times 3. So it looks like what we actually did here is we multiplied our numerator and our denominator both by 3. Look back at the model where we went from 1/2 to 3/6. Why does it make sense that we multiplied the numerator and the denominator by 3? Say it out loud. We multiplied the numerator and the denominator by 3 because we increased the numerator and the denominator by 3 times as much in our drawing. When we partition the fraction with the larger pieces into the one with the smaller pieces, we made 3 times as many parts that we were referring to, and 3 times as many total parts in one whole.